Consider the marginal profit and initial condition provided below. So this is question number 13, and it says to consider the marginal profit. Here we have the marginal profit and the initial condition. Here's the initial condition provided below. So this question is not concerned about deriving the marginal profit or finding the marginal profit. The marginal profit is already provided. Here is the marginal profit. So what it requires from us with regards to the marginal profit is to find the profit function for a given marginal and initial condition. Okay, so we have to find the profit function for the given marginal profit and initial condition. So it's like the opposite of differentiation. Okay, because to find the marginal profit, you have to differentiate. So to get back the profit function, we have to do the opposite of differentiation, which is called integration. And that is another branch of calculus, all right, which is integration. And that will give us the profit function. So when you integrate the marginal profit, we will get the profit function. In that process, we have to use the initial condition. So here is the opposite to the power rule. Okay, so we are integrating. This is a symbol for integrate. When you see this symbol, you say integrate. So we are going to integrate ax to the n with respect to x. So what you simply do, you keep your a and you put it over n plus 1. So you add 1 to n and you put that under a. So a over n plus 1. You keep your x and then n now you add 1 plus 1 to n also. So it's a over n plus 1. Whatever n is, x raised to n plus 1 plus c. C is called the constant of integration. All right. So we would like to integrate minus 20q plus 913 with respect to q. Okay. The general formula is has x as the variable, but here we have q. So a is minus 20 and n now will be 1. Okay. So we have minus 20 over 1 plus 1, q raised to the 1 plus 1. Okay. Plus, now 913 is just a number. So when you are integrating a number, okay, we can even write this down as a rule. You just simply add the variable to it. Okay. So therefore now, if you want to integrate, let us say a by itself alone, any arbitrary number you want to integrate a, for example. So therefore, that will just be ax plus c. So you just simply attach the variable to that number. All right. Here we want to integrate 913 with respect to q. Okay. So therefore now, what will simply happen is that we're just going to add q or attach q to 913. Just multiply q to 913. So q will just appear at 9 by 913 plus c. So now we have the profit function, but it is missing a value, which is c. Okay. So that's a profit function. We can even write the profit symbol here, which is pi. So we're going to write pi in terms of q is equal to minus 10q squared plus 950q plus c. So now we need to find the value of c. So that is where now the initial conditions come into play. Okay. Remember the initial conditions say that when q is 3, pi of 3 is 7,559. Okay. So what we are going to do, we are going to solve for c by putting 3 in the place of q and putting 7,559 in the place of profit. Okay. So when the quantity is 3, the profit is 7,559. And then we are left to c, we can solve for c. So a simple case of computation, minus 10 times 3 squared, that's minus 90. because 3 squared is 9. 9 times 10 is 90. 914 times 3. Verify if it is 2,739. We subtract 9 from that. We have 2,649. And we simply subtract from 7,559. We subtract 2,649. And this will give us a value of C. So now we have the complete profit function. Okay. Remember, we have to integrate the marginal profit to get the profit function. But when you are integrating, you have a integral constant, the constant of integration. And that is why the initial conditions were provided. We substitute 3 in the place of Q, 7,559 in the place of the profit, and then we solve for the value of C. So now we have the complete profit function. So now part D says to determine the production Q that will yield a maximum profit. So what we need to do, we have to use the marginal profit function. Remember, to maximize any function, we have to differentiate, equate the differentials to 0, solve for the variable, and may not substitute that solution into the original function. So now we have to maximize the profit. We already have the marginal function profit. We already have the gradient function, okay, that was provided to us, which is d pi over dq, which is minus 20q plus 913. So now we simply have to equate this to 0, okay. Now we have a minus 20q plus 913. So we add minus 20q from the left so that we can have it on the right as a positive 20q. And then we divide by 20, 914 divided by 20 will give us a quantity of 45.64. Okay, so that will be the quantity that will yield a maximum profit. Now, part C says to calculate that maximum profit. So now we can take that value of Q and substitute it into the original profit function to calculate the actual profit when quantity is 45.64, and that will give us the maximum profit. So we go to the profit function. Okay, we know what the profit function is. We already obtained it via integration. Here it is. So what we simply needed to do was to substitute 45.65 in the place of Q and solve for profit. So you have minus 10 times 45.65 raised to the power of 2 plus 914 times 45.65 plus 4,910. And please verify if this gives us a profit value, which is maximum profit of 25,749.23.